Today's lesson, we are going to be working on simplifying radical expressions by using the quotient property of square roots. All right, one of the main things that we do when we're dealing with square roots, when we have fractions, is the fact that if I have a fraction within a radical, such as this one, it can be broken apart, such as that. So, for example, if I have the square root of, let me just think here for a second, 36 over 9. Now, we know that 36 over 9 is equal to 4. So the square root of 4 is 2. All right, so we're aiming for a 2 here. Using the square root, the quotient property of square roots, I could take this and break it apart into the square root of 36 over the square root of 9. Now, the square root of 36 is 6, and the square root of 9 is 3, and 6 divided by 3 is 2. So you can see that this does work in square roots here. All right, so step one, use the square root property. We're going to be doing something called the rationalizing the denominator. First thing, let's look at our first example here. We want to take our fraction and reduce it if possible, make our job easier. So 35 over 15, I can reduce out 5 out of both the numerator and the denominator. So I'm dividing both of these by 5. And so what I really have here is the square root of 7 thirds. Makes our job easier getting the number smaller. Okay, the next thing that I want to do is I want to take that and break it apart into the square root of 7 over the square root of 3. Now, a trick that we use quite a bit in math is multiplication by 1. We're going to multiply this fraction by 1. But remember, there's many ways you can have 1. We could have 3 over 3, or we could have 4 over 4. Those are all different variations of the number 1. My number 1, I'm going to choose to get rid of my square root in the denominator. So my number 1, I'm going to choose to make it look like this. The square root of 3 over the square root of 3. Okay, and the reason I'm doing that is because my denominator here is the square root of 3. Now, watch what happens when I do this. That's going to give me the square root of 7 times 3 over the square root of 3 times 3. From yesterday's lesson, we know that on the denominator here, I can cancel out 2 and bring out 1. So what I will have on top is the square root of 21 over 3. That is called rationalizing the denominator because we've taken the radical out of the denominator now and moved everything up to the top. Let's take a look at my second example here. Okay, so on this one, I cannot reduce the fraction 3n over 8, so step 1 is out of the question here. So all I'm going to do is I'm also going to take a look at the square root of 8 in that denominator. Now from yesterday, the square root of 8 is equal to the square root of 2 times 2 times 2. And you'll recall that if we can cross out 2, then we can bring out one of them. And so what I have here, the square root of 8 is actually equal to 2 square root of 2. So for this problem, we're going to have the square root of 3n over 2 square root of 2. Now, for my trick of multiplication by 1, it's not a trick, but it's just a math thing, we're going to multiply both the numerator and the denominator to get rid of the square root of 2. Alright, so I want to choose my value of 1 to look like this, the square root of 2 over the square root of 2. Okay, so now we're ready to go through it with our multiplication. On the top, I've got the square root of 3n times 2, which will give me 6n. And on the bottom, I've got 2 times this. Let me get an arrow going here. I have 2 times the square root of 2 times the square root of 2. Now, the square root of 2 times the square root of 2 is also 2. So really what I have is 2 times 2, which will give me 4. And that is the simplified version of our original problem. Moving on. Now let's talk about something called conjugates. Conjugates. All right, binomials of the form, and let me get that. You can't see me pointing at the screen. Binomials of the form a root b plus c root d and a root b minus c root d where A, B, and C are rational numbers, are called conjugates. Now notice the only difference between this term and this term is the fact that one has a plus and one has a minus. Now, we have two conjugates right here, 2 plus root 7 and 2 minus root 7. I want you to observe what happens when I multiply these two conjugates together. 2 plus square root of 7 times 2 minus the square root of 7. We're going to be using the FOIL method on this, so when I multiply the 2 times 2, I get 4. When I multiply the 2 times the minus square root of 7, I get minus 2 square root of 7. When I multiply the square root of 7 times 2, I get plus 2 square root of 7. And when I multiply the square root of 7 times the negative square root of 7, I get minus 7, because I got the square root of 49. Okay, now when I combine like terms, notice that these two terms are opposites. They will cancel out, and basically what I have is 4 minus 7, which is negative 3. When you multiply conjugates together, you get rid of the radical expression within the terms. Okay, so we're going to use that fact to simplify this. 3 over 5 plus square root of 2. Now recall, multiplication by 1 can look many different ways. I'm going to choose my 1 to be a conjugate of the denominator. Okay, so my 1 is going to look like this. 5 minus the square root of 2 on top and on bottom. Since both the numerator and denominator are the same, then the value of the number that we have in red is 1. So the value of this thing is 1. Multiplying by 1 does not change the value of my original numbers. It changes the appearance of it. So, carrying through on this, we will have 3 times 5 minus the square root of 2 over 5 plus the square root of 2 times 5 minus the square root of 2. Okay, so now we'll just on the numerator, we'll distribute out 3 times 5 is 15. And 3 times minus the square root of 2 is minus 3 square root 2. On the denominator, we'll go ahead and use our FOIL method. I've got 5 times 5 is 25. 5 times the negative square root 2 is minus 5 square root 2. Square root 2 times 5 is plus 5 square root 2. And square root 2 times negative square root 2 is negative 2. Our middle terms will cancel out on this one. These two terms right here are opposites. So what I have now is 15 minus 3 square root 2 over 25 minus 2 for my denominator, or 23. Now, if I could at some point reduce something out of all the coefficients and all the terms, what I'm saying here is that if 15, 3, and 23 shared a common factor, I would reduce it out of this fraction to make a completely simplified expression. But this one cannot be reduced. That is it for today's lesson, it appears. Come back tomorrow for the next one.